Welcome to episode 65 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes the object so interesting to astronomers. So let's now turn on the random number generator.
Sieben, drei, neun.
And the generator has returned the coordinates of 12 hours, 13 minutes, 29.5 seconds for ascension, and plus 10 degrees, 2 minutes, 30 seconds declination. These coordinates point to a sun-like star at a distance of 103.7 light-years or 38.1 parsecs in the constellation Virgo named HD 106252. This star is not just a sun-like star in that it fuses hydrogen into helium in its core. It's actually almost identical to the Sun. Its mass matches the mass of the Sun to within a couple of percent, and its surface temperature is close to that of the Sun, so it has the same yellow color. It could cosplay as the Sun at comic book conventions. If you do a Google search in HD 106252, you won't see any photos of the star at the San Diego Comic-Con from 2015, but you will see that the star system is known on the internet for having an exoplanet, which is uncreatively named HD 106252b. The discovery of the exoplanet was published in a paper in 2002 led by Deborah Fisher, who had been working with a research group that had been using the Keck and Lick observatories to carefully observe hundreds of stars for exoplanets. The group identified the presence of exoplanets by how their gravity caused slight changes in the motions of the stars that they orbited. HD 106252b was identified to be about 7 times the mass of Jupiter. The exoplanet orbits the star at an average distance of 2.4 astronomical units, or AU. For context, the distance from the Earth to the Sun is 1 AU, the distance from the Sun to Mars is 1.5 AU, and the distance from the Sun to Jupiter is 5.2 AU. So if HD 106252b was in our solar system, it would orbit within the asteroid belt. However, HD 106252b is on a very elongated elliptical orbit, so it can get as close as 1 AU or as far as 3.8 AU from its star. Now, having said all of this, 80 other stars with exoplanets had been discovered before the exoplanet in orbit around HD 106252, so it was not that exciting when it was discovered. HD 106252b also didn't stand out in any specific way when it was discovered and doesn't stand out now. For example, it isn't Earth-like, its orbit, although elliptical, isn't all that unusual, and no interesting measurements have been made of the exoplanet's atmosphere, so no one has really paid much attention to it after its discovery. To put this into context, think of all the great musicians that have worked with Motown Records. The most famous musicians would include Michael Jackson along with the Jackson 5 and Diana Ross along with the Supremes and Smokey Robinson and Marvin Gaye and Stevie Wonder and the Temptations and the Four Tops and so on and so forth. You can think of HD 106252b as being as famous as musicians who rank much lower in the list of greatest Motown artists like Geno Parks, the Velvedettes, and Bobby Taylor and the Vancouvers. So, while HD 106252's exoplanet has sort of faded into obscurity, astronomers have become very interested in the star for very different reasons. It turned out to be very useful as a calibration source. In the early 2000s, astronomers working with the Spitzer Space Telescope, which performed observations in the infrared that weren't possible from the surface of the Earth, wanted to develop a better way of calibrating their telescope. The measurements made by many telescope detectors, including the infrared detectors on the Spitzer Space Telescope, are often in some sort of electronic units that do not necessarily indicate exactly how many photons are coming from the objects that astronomers are looking at. To calibrate these instruments, astronomers point their telescopes at objects where the total energy output is very well known. When they do this, they will make measurements with their detectors in electronic units that they know correspond to a specific amount of observed energy, and they can use these data to create conversion factors between the electronic and astronomical units that can then be applied to observations of objects with unknown brightnesses. George Ricci, who was the lead scientist for one of the instruments on the Spitzer Space Telescope and who is also very well known for wearing plaid, was one of the people who carefully investigated this topic. He demonstrated that because the spectrum of the Sun and the infrared has already been very carefully measured, it was possible to calculate the infrared brightnesses of other stars that looked very similar to the Sun, and it was possible to use those stars as infrared calibration sources. However, it's not possible to use just any star that looks like the Sun as an infrared calibration source. First of all, the stars have to be bright enough that they are easy to detect with infrared telescopes, but not so bright that they effectively blind the instruments. Or in other words, infrared telescopes can't just point at the Sun as well as a few other really bright Sun-like stars in the sky. Second, the stars already have to have reliable brightness measurements at wavelengths either in or near the visible part of the electromagnetic spectrum. Third, the stars cannot show any signs of being surrounded by any type of dust disk, which would produce its own infrared emission that could not be as easily estimated using models of the Sun's spectrum or any other models. Now, I had mentioned that HD 106252 looks so similar to the Sun that it could be cast as Antipholus of Syracuse in Shakespeare's Comedy of Errors. Because it is relatively close to the Earth, it's bright, but not too bright, and its brightness in and near the visible part of the electromagnetic spectrum has been fairly accurately measured. Also, even though it has an exoplanet, it does not have a dust disk, so virtually all of the infrared emission from the star system comes from the star itself. So HD 106252 was selected for use as an infrared calibration source for the Spitzer Space Telescope. However, this telescope is not the only infrared telescope to ever operate in space. Other telescopes could also potentially use HD 106252 as a calibration source, and one of those telescopes is the James Webb Space Telescope. While the James Webb is often described as a replacement for the Hubble Space Telescope, the James Webb Space Telescope was actually designed to observe infrared light with wavelengths far longer than what the Hubble Space Telescope could ever observe. This means that the James Webb also needs to observe infrared calibration sources so that the astronomers know how much light they are observing from the objects that the telescope looks at. So, the James Webb will be looking at many of the same calibration sources used by the Spitzer Space Telescope, and that includes HD 106252. So that's my summary of why astronomers spend so much time looking at HD 106252. And the location on the Earth's surface corresponding to the position of HD 106252 in the sky is in the middle of the Pacific Ocean. Despite the fact that the Pacific Ocean has lots and lots of island chains as well as various underwater seamounts, this location really isn't near much of anything. It could be described as over 1,000 kilometers southwest of Johnston Atoll, over 1,000 kilometers north of Howland Island, or over 1,300 kilometers east of the Marshall Islands. It's a really isolated part of the Pacific Ocean. The website for this podcast is www.randomastronomicalobject.com. You can visit the website to download episodes of the show, read information about the astronomical objects, view images of those astronomical objects, look up additional reference information, and send me random feedback. And I did receive more random feedback before recording this episode. Richard wrote in to say the following. Hi George, I just discovered your podcast and wanted to say after listening to the first 8 episodes today, I'm really enjoying it and learning a bit. Love the quirky humor, and the short length is great for listening to while hanging the washing or doing some other short chores. Fun and illuminating. Thanks, Canberra, Australia. It's nice to know that my podcast is a good accompaniment to household chores. If anyone else would like to write in about how they enjoy learning about the odd astronomical object while washing their dishes or dusting their furniture, they can reach me through the contact page on the podcast website or contact me via Facebook or Twitter. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Endy at www.sasha-endy.de, and the sound effects are from the Free Sounds Project at www.freesounds.org. Thanks for listening.